All right, I thought I'd show you, starting from the front of it here, looking down, this table here that you see with the sacrificial board. This is 9.5 feet by 4.5 feet. And so I can do a full-size door or full-size panel and whatever I want to do on that. But this table I built from scratch using Baltic birch plywood and 2x4s. The Baltic birch plywood gives it the strength needed for a rigid surface. And inside this 2x4 frame here is a honeycomb, which gives it rigidity on the top side. No flex, no give at all. This is just as strong as it can be. And the only thing that I really don't like about this particular machine that I made is that I have these belts here, these drive belts. And these drive belts tend to wear and will fray and crack, maybe even split from time to time, and they have to be changed. And they're good, they keep a pretty good track of everything, but sometimes they do slip, and when they slip they'll ruin your work. And my intention is to later on put a ball screw, which is the same thing you see here, that controls the router motor itself. This particular router motor is a 3 horsepower water-cooled router motor, and it is strong, and it's very powerful router. Primarily though, I've been doing smaller projects on here, and you see I've got a jig, and this jig is so that I can line up whatever I'm going to do. If I'm going to engrave a cutting board or cut out a cutting board or something like that, I can line this up and center it, zero it with a stepper motor and with the router, and it will carve what I want it to do. You can see some of the other things I've done on here, oval shapes and so on. These stepper motors that you see here, these are oh man, it's a high-powered stepper motor. If you look here, you can see the specifications for it right there. But these stepper motors control the direction of travel on the X and the Y here. And over on there, the machine itself on the router controls the Z axis, the up and down. So you got the left and right and the front and back. And all three of these work together to produce what you want to do, what you carve out of it. I've carved a full-size sign on this machine here and worked on it here. You can see some of the outline of it. This sign is a sign that we put up at our church, made for it, and using a waterproof MDF board. Waterproof MDF board will last for a long time before you have to work on it again. But this particular MDF is not. This is a sacrificial piece on the top here. But when we come around, we have limit switches on it that control it and stop it automatically so that it won't over travel. And if it over travels, it'll ruin the machine, so you don't want that to happen. You want to put those limit switches on it. You can see here, this is the carrier up top. It's also made of Baltic birch. It's braced and so on, and strong, and sturdy, and will not move around. The only problem, as I said, is this drive belt. This drive belt tends to slip from time to time, and when it slips, it'll ruin your product. So I'm going to put a ball screw on it, and I have the ball screws here already that I'll be using with it. These ball screws will give me the same length that I have now of 9.5 feet, and they'll be able to control a whole lot easier the direction of travel here without any slipping or giving or misalignment of whatever. So those are some of the things that we have to look at there. As we come around, I said I did the wiring of this thing. You can see the wiring harness coming from the stepper motors here, and it comes to the Z-axis motor for the router and the X and the Y stepper motors on each side to control that. I also made the electronics for it. I built these from scratch, and I used a controller here. This controller comes down to the stepper motor control boxes, and this part tells these parts to tell the stepper motors what to do. The inverters that you see here on the right, these inverters control the power of the stepper motors, and they are run off of the control box, and they are coming down and then over to the motors themselves too, giving it the power it needs. That's what the little red and black wires are for, and the green, of course, is the ground. But these control boxes have the automatic shut-off emergency stop over there. When something gets out of whack and you want it to shut down, that's what that button is for there. This control here allows you to manually work it from top to bottom. It allows you to manually operate the router motor. From there, it backs up to the computer. The computer that I have, that I use, is a Sony computer. Its sole purpose is this machine. This is all this computer is for. Well, I say it's all it's for. I used it in my pistol training. I also have a concealed carry class that I teach, and I have programs on here to teach with, apart from the National Rifle Association that we do that with. Turn this off just a second. Now this computer has two programs on it that I use for the machine over there. It has a Mach 3 program. It has a Mach 3 program that you see there. You can use this for milling. And we'll open that up and let you see that. Okay, this is what the program looks like to begin with. When you first open this machine up, to find a program that you're wanting to cut, you'll have to open it up, hit the reset button, and then go in and zero out all of these. Those zeros are where the position of the router head is at the moment. That is in a zero position, and that's where we'd start carving from. But to get to this program here, you can come in and upload or load a code. This is called G-code. G-code controls everything about the machine itself, and where to cut, and how deep to cut, and when to cut. And there are several things in here. You can look at your library, and you're looking for a program that's a tap program, and you'll want to look in in this piece, so then we'll look at our documents. Let's look at our downloads. And in these downloads, you see here different programs that we have. These are carved programs that I wrote for this part here. But if you want to do a fish, for example, a 3D fish, I have the program that I carved for my son there. Let's look at that. And what has happened here is it's going to be in an oval shape that I've carved in. And this is the schematic, or the diagram, or the code that we wrote to cut this with. And from here, When we zero out our machine and turn our machine on, let it come up to speed, we can start from here. And what we do is just hit the cycle start button. And I'll just show you what happens there. As the cycle starts, the machine comes in and positions where the router is at the moment above, about a ½ inch above the work. And it'll sit here for about 6 seconds before it'll start. You'll see that it starts cutting and it goes through the code that we wrote for this particular function here. This is a 3D carving that we're making of a bass. My son loves to fish, and so I couldn't cut him out this bass, and he uses, I put it on a walnut box so that he could, you know, have his family keepsakes in it, and it mentions the fishing also. But you can see how it cuts there, and it cuts rather quickly. We probably need to slow it down. That's probably a little too fast, but that we can do with these controls here with the spindle and the feed rate. We have the different tool information and the controls. We can edit the G code and have it do in other programs or other parts of the program. We can have it run in reverse, depending on your tool itself. But this is a neat program that we use to cut out the G code or cut out the pattern that we want on the wood. Okay, we'll close this down. Ask if you want to save that. No, we don't want to save it because we'll have to change it when we come back. The other part of this program to using the machine is called VCarve Pro. VCarve is a company that produces files or produces directions or programs, or if you wanted to create a new template or a new file or something like that, this is what Vectric can do. This is a user-friendly, I think, program, and if not, if you find it a little difficult, there's all kinds of tutorials from Vectric online about how to use it and what to do with it. But I find it, for me, being a amateur woodworker, that it's a very useful program. I made some plaques for my son-in-law, who is a manager of a manufactured home place, and I'll show you what that looks like. Well, undoubtedly it was the wrong program. Instead, I'll show you a carving of the Lord's Supper that I did, and these carvings I make out of maple and walnut, and also out of purple heart. They're about a 24-inch wide by 12-inch tall carving on a 3/4 inch thick of wood. But this here is the program as you want it to carve. If you want to see it simulate, we'll show you how it simulates there. Look at our tool paths of the 3D finish. We'll come in and look at the wood. We're going to preview our tool path. And when it cuts out on the machine, this is what it finishes up to. It's a very beautiful piece of work there. And selling this piece of work, working on this, I'll tell you about it. On this particular carving, as big as it is, takes about 20 hours of carve time because it's a 3D piece, and you don't want to get in a hurry. You're using a small tool, and you're carving on that, and so it just takes 20 hours to carve this out. My machine is not fast. I'm sure there are other machines out there that are faster and can do it quicker, maybe even half the time. but for me in my homemade machine, this is plenty fast for it. The only problem is that you have to be sure your power supply, which comes from our Electric Power Association, you have to be sure that that power supply is stable. Our Electric Power Association is not stable, so I have built a solar generator to operate the machine with, and it's backed up by a gasoline powered generator. But I'll show you another generator that I'm working on. This is an inverter generator that I'm working on for my son in Texas to power his water well when the power goes down. If people from Texas are familiar with things around Glen Rose, Texas and around in that area, you know that the power is just not very stable. The power in Texas is not stable anyway. But when I finish this, it'll have this 5,000 watt inverter here. This is a single phase 240 volt. Now his water well works off a 240 volt split phase. So I had to change this to a split phase power system. And so that's what this grow watt box here on the right is for. This takes the 240 watt single phase electricity and converts it to a double phase. And then it goes into the box here. This is the distribution box, which goes down to the plugs that I have for it to power his electronics that he has. And it's protected by breakers and fuses. It also is being solar charged. It has a charge controller here. The bad part about this system is that it's a 12 volt inverter. And if you're familiar with 12 volt inverters, the bigger power, like a 5,000 watt, the bigger control cables you have to have, the bigger battery cables you have to have. This is a 4 gauge, 40 gauge, anyway, this cable is 3/4 of an inch round, and it has to go to the batteries. It has to go to at least 4 12 volt batteries, 100 amp deep cycle marine batteries. And these deep cycle marine batteries at 100 amps will run this system and run it in an efficient manner, or effective manner. It's preferable if you had 8 12 volt deep cycle batteries, but 4 will get you by in an emergency situation. Plus I've had it set up to where it will charge off of the grid, so that the grid will, when the solar disappears on it, you can charge it up from the grid with a generator or with the power company. Back to my machine, I believe strongly that anybody that can read and understand has just a micro amount of common sense can build something like this. You may say, no, you can't do it. But what caused me to do it, I knew what I wanted. I knew I wanted a big machine that would carve a door panel, for example. Door panels carved will bring a lot of money. People look for a good 3D carving door. I also carve mantles for fireplaces with it. They sell real good. I can sell a mantle for $500 or $600 carved off of this machine. And so it'll supplement my income. If I had to buy this machine new, if it was a commercially made machine, you're looking at between $10,000 and $20,000 for a machine this size and the capabilities that this one has. I can cut up to 8 inches thick on it. If you bought this machine, as I said, it'd be between $10,000 and $20,000. The entire amount that I have in this machine from start to finish is less than $2,000. That's all the parts and everything like that. The electronics, the computer program, everything is less than $10,000. excuse me, less than $2,000. Of course, you got a lot of man hours put into it in building it, and it's just a labor that you would enjoy. If you enjoy working with your hands and building things, then you can do something like this. There are DIY projects on CNC machine online that you can get ideas from and how to do it. But the thing is, you need to start somewhere. It's a very good system, I think. It has a dust collection system that I turn on when it's carving. It creates a lot of dust. You want to wear a dust mask, but you also want to evacuate that dust to the outside. And that's what this hose does. It runs over to the manifold over here and comes down and brought into the separator here at this trash can. And then it goes through the vacuum pump here and then exits the building. It's a real efficient dust collector. I'm not going to bother my neighbors with the dust that goes outside because I don't have any neighbors. But if you do have neighbors, you might want to consider a filter bag and leaving it inside the building. I have a filter bag for this one, but I don't want to. I like the way I have it going. So that's the dust collection system. Have a power system here. This power system plugs into a 240 volt system, and this power I can run off of either 240 or 120, either one. I split this where it would run 120, but it also does 240. And out of that, if I go to the water pump is here. We use an antifreeze solution, but this is an inverter to take 110 and turn it into a European 220. You know, the United States doesn't recognize that type of electricity here. We either 120 or 220, but this takes the 120 and converts it to 220 on a 100 watt output here, and then it comes over to run the inverter itself. Comes up to this control box, which is the inverter control box. You can control whether it starts or stops or runs, how fast it runs. You can program it that way. It's a kind of a complex program, but you can see it's 220 volts, 2.2 kilowatts. So if I had to say anything at all about this machine, is that it was fun to build. It took me about a year to build it, to understand how to build it, to understand what the parts do and how they function. And but as I said, it took about a year to do. But I enjoyed it, and I've enjoyed using it. If you have any questions or comments about this machine and how I use it, please feel free to comment. I'll try my best to get back to you and answer that. Thank you.